Okay guys, as requested, I'm going to do a video of some examples on your second set of video notes in the practice questions that was on factoring polynomials. So I will do one from each section here. Well, I already did the GCF, so I'll start with the difference of squares, okay? So the rule for factoring difference of squares, you can see right here. This is what we're going to be using. So you can use this when you have a perfect squared term subtracting another perfect squared term, okay? And that's going to look like two binomials being multiplied together. So in the first, let's actually spread these out a little bit. In the first spot of each binomial, you're going to have the square root of the first term. So the square root of 36w squared is going to be 6w. So that's going to go in the first spot here. And then in the second terms, in both of these, you'll have the square root of the second term, 25, which is 5. Okay, and then one's going to be positive, one's going to be negative. One's going to be addition, one's going to be subtraction. Easy as that. And there's your final answer. That's the factored form. So we're not solving anything here, we're just factoring. Okay, for perfect cubes, we saw in the video that this is, that this is what it looks like when it's in factored form. So this is going to be what we're looking at here. So looking at number 7, let's just set up our parentheses first. So we know what we're going for here. And then with the perfect cubes, actually with all of these, I would actually recommend putting in your signs. So we have positive, negative, positive. Okay, and that will make it really easy. So we're going to be adding here, subtracting here, and adding here at the end. Okay, so now that we have all of that in place, we're going to take the cubed root of the first term and the cubed root of the second term, and we're going to be putting those in for this x and y value. Okay, so the cubed root of h cubed is just h, so h will go here. In this spot here, we're going to put the cubed root, whatever the cubed root is, squared, so that would be h squared. Okay, and then the cubed root of the second term of 125 is going to be 5, so 5 is going to go here, 5 squared is going to go here, and this middle term here will just be the cubed roots being multiplied by each other, so then we'll have 25h. And that is your final answer. There's the factored form. Okay, let's move down to the difference of cubes, number 11 here. So let's set this up the same way by popping up those parentheses first and putting the signs in, just so you can keep track. Okay, and then you're actually going to be inputting the exact same types of numbers in the same place. So the cubed root of this first term here is going to be x, so we'll do x here, x squared. The cubed root of 343, I believe, is 7. Correct me if I'm wrong, I'm pretty sure it's 7. And then 7 squared will go here, which is 49. And then we'll multiply them together, 7x. And there is your final answer. Awesome. Okay, I'm kind of blowing through these, so you might need to stop, pause while you're working on some of the other problems. Okay, let's take a look at 15. This is just trinomial factoring. It doesn't really have a special name, but this is, like I said earlier, this is probably where you've had the most practice here. So we're looking for, so these two numbers have to multiply to get negative 30 and add to get negative 13. It might help for you to make a list of factors of this last term here if it's not clear what you're going for, but in this case it actually is pretty clear. Two numbers to multiply together to get negative 30 and add together to get 13. Negative 13 is going to be 15 and 2. So let's go ahead and write 15 and 2 here, and then our variable here. Okay, since they're multiplying together to get a negative number, the only way you can do that is have one of them be positive and one of them be negative. And your middle term is also negative, so your bigger number here is going to have to be negative. So you're going to subtract 15 and then add 2. That's how you get negative 13. And that is your final answer for this one. Let's look at one of these that has a number out front, okay, because this is a little bit trickier here. So the way that I'm going to demonstrate this is called the slip and slide method, okay? So you may have heard this before, you may not have heard this before. This is what I find is easiest for students to do, so I'm going to quickly demonstrate it here, and then if you've never seen this before and you're very confused and you want to learn it, then you'll need to come talk to me and we'll set up a time to go over that, okay? So what we're going to do first is we're going to take this 2 out. So let's just make a note here that our a is equal to 2. Okay, and then we're going to take this out of the first term and we're actually going to multiply it by the c term, by the third term here. Okay, so we'll rewrite this as d squared minus 13d minus 14. And now we're dealing with a regular trinomial that doesn't have this front number here. Okay, so the same method here. 2 numbers to multiply together to get negative 14, add together to get negative 13. Again is pretty simple here, so we're going to do 14 and 1. Our 13 is negative here, so we'll subtract the 14 and add the 1. Okay, this is not your last step, okay, because we did this slip and slide thing in the beginning. We can't leave it like this because this is actually not equal to what we started with, so we need to kind of go back and reverse that. And the way that we do that is we'll just divide both of these terms by that a number here. Okay, then we will simplify these fractions. 1 over 2 is actually not, you can't simplify that into a whole number, so we'll take this 2 and we'll move it up in front of the d right there. Okay, and then this term will simplify to 7 over 1, and then the 1 will take up in front of the d, which we actually don't show, obviously, multiplying by 1. So then your final answer is going to be 2d plus 1 times d minus 7. Okay, and if you multiply this out, you'll see that it does, in fact, equal that trinomial in the front. Again, if this is confusing, come talk to me, send me a message, we'll set up a time to go over this slip and slide and I can give you some practice, or you can practice on your homework. Okay? Alright, let's move on to 21. So this is in the 4 terms. This is factor by grouping is what this is called. It's kind of cool stuff. Once you get the hang of it, it might be kind of confusing at first, but what you're looking for is you're looking to group these terms. Just a quick note here, if this was a subtraction, we would include it in this term here and then add an addition in between. So I can show you that on a different one. But since it's addition, we don't need to worry about that. We'll group the second set of terms there. And then, like I said in the video, we're going to factor this and we're going to factor this and see what we get. So if we're just looking at this first set of terms here and we want to factor it, we see that we can factor out, I think, 2 h terms. So if we factor out h squared, in the first set we'll be left with 2h minus 3. Does that look good? I think that looks good. And then here we'll factor out the second set of terms. We'll keep this addition here. Here we can factor out a 3 from these guys. So factor out a 3, we're left with 2h minus 3. Does that look familiar? It looks familiar to me. Okay, so now we have 2 terms that are the same. 2 factors that are the same. Now we're only down to 2 terms. This is 1 term since it's all being multiplied, and then you're adding a second term. Since we have this same factor in both of these terms, we can actually factor that out. And this is where it gets a little bit messy. You might have to keep track of what you're doing, but we're going to be factoring out this 2h minus 3 term. Okay, so if we divide it out of this first term here, we're left with h squared, right? And then if we factor this out of the second term, we're left with a 3. It's going to be positive because these are both positive. So h squared plus 3. And that is actually your final answer here. This is a factored form of what we started with. Okay, so you might need to go back and rewatch this step by step. If you are still confused, you can look up videos. This is called Factor by Grouping. You might be able to find some other examples and some other videos that might help you. Khan Academy is a favorite of mine. I use that a lot in college, so I would recommend starting there if you need more videos. Or you can always, like I said, come talk to me. We can set up a time to go over this. We can do some in class, whatever you guys need, okay? So that's factoring by grouping with 4 terms, and then factor completely. So this one, like I had said in the video, we're always going to be looking for a greatest common factor first, because these other factoring methods will not work if you don't factor the greatest common factor out completely, okay? So let's look at number 25 here. Step 1, like I just got done saying, greatest common factor. Do we have a greatest common factor here? And it turns out we do. We have 5n can be factored out of this. So if we factor out 5n from this first term, we'll be left with n to the 4th. And then the second term will be left with minus 36. So 36 times 5 is equal to 180. Okay, and then now you can see that, so this is going to be a big indicator. I think by now you guys would see the number 36 and know, oh, that's a perfect square. I should be looking for perfect squares. And n to the 4th is actually a perfect square too, because if we square n squared, that's n to the 4th. Okay, so we can take the square root of n to the 4th and get a whole number. So then now we're going to be working with the difference of squares. So we'll just drop this down because we're still multiplying by 5n, and then we'll factor what's inside the parentheses here. Factoring by difference of squares, remember you have 2 binomial terms, one's positive, one's negative. The square root of this first term here goes in the first spot, and the square root of the second term here goes in the last spot. And that is, that's it. So now you have 3 factors being multiplied together. If we multiply them out, you'll get this initial binomial there. All right, so there's your video on some examples of factoring. So it looks like these ones in this section here get pretty tough. So make sure you are keeping track of what you're doing so that it doesn't get too messy, okay? Always check for greatest common factor first. And of course, let me know if you have any other questions.